Please, sir, unmute yourself.
I already am unmuted, but I'm waiting for our colleague to enter. We have 85 person was participating. Now we just 50. So I'm waiting
Oh,
for most of
okay.
us to enter. Okay.
Okay, thank you, sir. Thank you.
Not to have any missing part for anybody.
Thank you very much.
Yes. So now let's continue. As I said, for alpha aluminum oxide, it's a little bit different because in such a case, 3 layers will be formed. In such a case, we are building up another, you can say, additional 2 fine layers on the surface of the main ceramic module. This happened like this. Let's see. I will explain about what I saw already in one factory, the flat sheet membrane, just as I said, held on vertical position. Then the robot started to spray colorful, as I said, solution with very fine particles of alpha aluminum oxide, also 1 micron particles. Let's say the first layer will be 5 micron particles just to build outer layer around this 10 to 50 micron particles. So the robot hold it, fix it in vertical position. It goes in the production line. Recognize which part of the membrane covered or not. If there is any manufacturer defect due to the absence of some spots not covered by fine layers, so they can recognize it. So the robot already can fix it, started to spray it accurately. As they say, let's say with the pink color solution, with a little bit coarse 5 microns, let's say, particle of alpha aluminum oxide. After that, it passed to a little bit drying compartment, then to another compartment where another layer of spray with 1 micron or finer particles even sprayed with different color to see also the coverage of the layer to be consistent on the membrane surface as we see. So after these 2 layers of coat on the alpha aluminum oxide ceramic membrane surface, it passes through the oven in the same way, as I said, to form this final plate of ceramic membrane. Can we call it spray coating? Yes, of course, it's spray. I just said spray coating. You can say spray coating. For alpha aluminum oxide, spray coating. But for silicon carbide, it is submerged coating. Submerged coating. You take the plate, just fix 2 covers from both sides, right and left, to keep the holes inside or the channels, and then submerge it and take it out. Okay? So it is, as I said, forming just one layer of alpha aluminum oxide fine particles, 1 micron, and for of silicon carbide. For alpha aluminum oxide, it passed through 2 layers, as I said, one is the inner one or the middle one, let's say, around 5 micron, and the outer final layer, which is give the membrane its nominal size, which around, as I said, 1 micron, sorry, or less than that even. So after that, as I said, in both cases, it go to the dryer and then to the furnace to make incipient melting again at lower temperature, because we are dealing with very fine particles or tiny particles, as we say. So this is, as I say, the process. Then come, as I said, the final production step to put this membrane inside a module, to put this membrane inside a module. This can happen by, as I said, gluing two plastic parts. This plastic part made from a special material which called nerol or polyphenylene oxide. That this is the name of the material, nerol or phenylene oxide. This phenylene oxide, the two caps, every one has, as I said, channel way to collect all filtrate or water from all these holes or channels to one main channel, then through these nozzles from both sides, left and right, where is suction take place. So it has a suction nozzle either from one side or from both sides, which is more efficient. This number of, as I said, nozzles from both sides or one side or whatever depends on the flux rate of the membrane. So we can, as I said, control the diameter of this to be sufficient for the flow across the membrane surface. The other option is just, as I said, to have this block or this, as I said, also phenylene oxide or, as I said, nerol part. It has a grooves to fit into these plates directly, and the water or the filtrate just gathered not through these two nozzles, but through one main outlet connecting the complete set of plates, Of course, this gluing material done by wax gun, you can say wax gun, this, for heating this wax stick or plastic stick to glue around the ceramic plates and the nerol plastic parts. So the same technique used also for here. We just use a resin, as I say, to glue this, the borders of the flat sheet membrane inside the as I said, polypropylene. It can be from polyethylene, like some manufacturers. So it differs largely, as I say. It depends on what? It depends on the compressional force which this, as I said, frame can take. If the number of modules you can just assemble over each other in one tower or one array, you can just, as they say, fix a set of membranes as we see here. You can see this set of modules just make in one stack over each other. You can see it. We have this, as I said, header connecting all the modules in one assembly, and this stack or tower, we call it module stack or module tower, can take many. You can imagine one over each other. Of course, this has, for example, male and female connection or adapters edges to be able to just clip the two modules over each other to hold it tightly without any movement. Okay. And you can imagine the number. There is, of course, you should consider the maximum numbers of modules you can fix in one assembly or one stack or one tower. So it depends on the material. For nerol or polyphenylene oxide, it has a little bit rigid structure or rigid characteristics. Very low hydrolysis. It has some characteristics. It can tolerate temperature over around 65 degrees Celsius. So this makes it very good in such application. But still, you can find, for example, for some wastewater treatment application, some modules of polypropylene or even polyethylene. Polyethylene used by some manufacturer. You know that polyethylene, it started to be, as I said, molten a little bit or a little bit ductile over 55 degrees Celsius. So Nerol give it, has, as I said, very strong characteristics. Okay, Nerol is used for, as I said, this frame because it has, as I said, very strong characteristics. This type, of course, of membrane, it is, as I said, the dual application, submerged and pressurized. It is also extruded by a special extruder and dried in the same time and processed exactly the same like silicon carbide, because it is mainly made from silicon carbide. It is mainly made from silicon carbide. You will find also alpha aluminum oxide, which I show to you inside the housing. It has similar manufacturing step like that of silicon carbide regarding the formation. What we should highlight this point. This is mainly because of the fouling matter. Of course, as much smooth will be the membrane surface, as much I will have less problem regarding the entrapped particles, which can be just, as I said, embedded inside the membrane surface. Of course, if I am dealing with such a surface, it's a little bit more smooth. You can see here the pores almost close to each other. You can make inventory about how much this size, how much finer size. So you can get, as I said, an idea about the different particle size which can pass through it. For, as I said, the rough surface, it will be, as I said, problematic a little bit in some applications. So it is just limited for another applications like the removal of large molecular weight applications, not the removal of particulate, as I say, which can be easily entrapped in this structure and have, as I said, fouling, easy to be fouled. So this is a very important point. We need to highlight it, as I say, the membrane surface, which we can see. Also, as we see that if we noticed, we'll find also another thing, that we have large, as I said, particle layer, which is the supportive layer, and we have very fine layer with very tiny, as I said, porosity. This porosity can be either by coating, by special techniques using plasma and vapor technique, which as I will show to you, or can be formed, as I say, by let's say special treatment for the membrane surface to give it special characteristics. You can see here for the polymeric membrane, we have different layers. These layers you can see it is, as I said, one, for example, here very smooth, the other side is rough a little. We can find one very tiny impures, one coarse impures. This is, as I said, depends on the manufacturer techniques used for it, and as I said, the treatment for the surface. Of course, this treatment, we already recognized it in the beginning as the hybrid membrane. The hybrid membrane, we already explained that it can be ceramic membrane with a special treatment, or it can be hollow fiber, polymeric membrane with a special treatment either. But what we are using this, as I said, treatment techniques for the membrane surface, just to give it special characteristics. What is the special characteristics? We can see here For example, this is BS, which is polysulfone membrane. We can see this polysulfone membrane layer. Here it is used, as I said, the large diameter one, 5 millimeter, 8 millimeter, used for wastewater or high large particulate separation, can be easily used for it. So we can find the two techniques, as I say, used for it. Either, as we see here, the coating with benzoquinone 1,4 benzoquinone polymer or material to give it, as I said, special characteristics, or we can use, as I said, the other technique, which is plasma vapor absorption technique, using, for example, here we use the two material, which is the acrylic acid and hydroxy ethyl methacrylate, 2-hydroxy ethyl methacrylate. So both of the two materials can form, as I said, layer over the membrane surface to give it special characteristics. What are these special characteristics we are talking about? We can see here, this is the membrane surface. Due to this, as I said, polymer forming, we have the polar molecule of water due to the presence of the double bond and oxygen, as I said, or it can be alkyl group. It can be many polymeric, as I said, functional group, as we saw in the previous one. You can see here, have OH, for example. It can have here the oxygen. It can have different types, as they say, of molecules or different types of protective layer, let's say protective layer or superficial layer on the membrane surface, either polymeric or ceramic, This is the hybrid type, as we say. This layer just have very important function. You can see here, the water molecules just started to be attracted to the surface, forming one consistent layer on the membrane surface like a protective layer. Of course, the water pass through here, but permanently there is, as I say, a layer formed because of what we call the hydrophilicity. This hydrophilicity is the surface tendency or potential to absorb or just attract H2O molecules or water molecules on the surface, like this, as we see it in the figure. This what we call hydrophilic surface or hydrophilicity. If I am able to increase the surface hydrophilicity, as shown in this figure, this, as I said, hydrophilic layer attract water molecule, and of course, if I have any particulate or things in suspension, it will never be embedded inside the surface of the membrane, or at least it will be, as I say, have a distance or outside the protective layer and will continue, as I said, if I'm using cross-flow filtration, it will continue to go to the retentate side. If I have, as I said, dead end filtration, this layer will make it very easy to backwash it or remove of the cake formed layer. So, as I said, these techniques using, as I say, nanotechnology, or as I said, different techniques now already developed, increase the hydrophilicity or the characteristics of the surface of the membrane, regardless if it is ceramic membrane or polymeric membrane, to give it certain advantages or characteristics for certain application. Can be, as I said, for water separation or filtration, can be for pharmaceutical industries, can be for the removal of certain type of dyes or some polymeric material or any other application we can find. or even wastewater treatment, because this hydrophilicity can guarantee or at least secure the membrane surface permanently. We will have, as I said, water molecule and sludge particles can be away or have a distance, will not be, as I said, embedded inside the membrane surface, causing permanent fouling for it. So it is, as I said, giving it special characteristics. We have another thing also. If we check, we will find this. It is like arm. You can see it is this chain. You can find this chain. It is like arm. That we call brush effect. What is brush effect? It is just on the surface of membranes. You can find it's like hands, or as I said, hair. You can say it's a hair layer on the formed in the membrane surface, just making as a protective or acting as a protective layer, prevent this, as I said, foulant or particulate particles to be attached or embedded inside the membrane surface. So you have either, as I said, increase the hydrophilicity, or to build up a layer, as I said, working as a separation, let's say separator layer between the membrane surface and the fluid which we are trying, as I said, or filtrating or processing. So this is, as I say, this. It is okay. So as I said, we already explained this hybrid, as I said, type membrane. I hope you got it, what it's mean hybrid. It is modification done to the surface of the membrane, regardless if it's ceramic or regardless polymeric, just to give it certain characteristics or advantages to be fouling resistance, or to be applicable for some separation process in some industries, like, as I said, pharmaceutical, or some other type of industries. For example, for the oil removal application, you can see this, as I said here, this technique. It is, as I said, with the big diameter, as I said, tubes. It is used especially for the separation of oil from water. You can use it really very effectively for crude oil treatment. You can use it for some contaminants removal. You can use it really for wide variety of applications to enhance, as I said, the ability of the membrane surface for separation. Yes. Is there any chance that the coated layer will be washed away in across flow filtration? Go is graphene oxide. I cannot understand what you call go as graphene oxide. You are focusing in graphene. I already highlighted yesterday that graphene is imporous. I will include it in the last lecture, maybe, to see, as I said, the researches already done on graphene for applications in ultrafiltration, reverse osmosis, and in general filtration. It needs really much, as I said, modification. Some membranes, especially ceramic membrane, has carbon atoms embedded, as I said, by nanotechnology, to give it also special characteristics. I can also explain it in further. It is all researches, and we can find it in scientific papers to show up this research for the development of new technologies. So anybody have any questions regarding today's lecture? Anybody has any question regarding today's lectures?
पर वो लिस्ट थी अटेंडेंस की चाहिए थी एक है लगानी थी
I hope I already explained all these main points. Yes, please.
Doctor, is this presentation the last thing you have mentioned? This coating is like a barrier for the fluency, so it cannot pass through it. So it's like a barrier.
Uh, yes, continue.
Uh, it's supposed to increase the hydrophilicity of the coated layer has to increase the hydrophilicity.
You have hydrophilicity, you have also oil philicity. Don't forget about it. Okay, so you are not talking about, as I said, only hydrophobic or hydrophilicity. It is a barrier layer, you can say. It is a barrier layer, just as I said, to prevent this particulate or particles, or for example, some cells. You know that some of these layers has also, you can say, can kill germs, even, you know that, and just prevent biofouling. We use it in reverse osmosis membrane to avoid, as I said, biofouling in fouling resistance membrane. We have already one lecture regarding that, the troubleshooting of in reverse osmosis, and I highlighted this point, the new, as I said, approaches in membrane technology. So as I said, you can find this layer which we are forming. It acts by two techniques. The first one is to increase the hydrophilicity, to be able to have, as I said, water layer as a separator, as you said, between the membrane surface and between the rest of the feed water, let's say, or the feed fluid. If we are talking about hydrophilicity, we are talking about water in such a case. So, as I said, any contaminants, as I say, or particulate will be formed over this layer. It will be easy to remove it by backwash, and in the same time by air bubbles coming from the bottom of the cassette. Okay. The other technique is, as I said, the brush technique, which we can find, as I said, for the reverse osmosis, and at the same time in the ultrafiltration membranes. You can find this brush technique, as I say, to remove scale, to prevent the scale to develop on the membrane surface, to prevent, as I said, in this, of course, scale in the reverse osmosis, but here in ultrafiltration to prevent fouling, particulate particles, microorganisms, viruses, bacteria, and others to be embedded or just form a layer or growth over the membrane surface. So I hope this point is clear. Okay. Any further question? Hello? Any further question?
No question, sir. Thank you so much.
Okay, my dears. So I hope you enjoyed today's lecture. I hope it was really helpful to have some informations, new maybe for some of us, and as I said, answered maybe some questions for others. We can, as I said, go through the notes. If any you have any questions, just please keep it for me for the next lecture. You are welcome anytime to send your questions on the, as I said, the page. And can we get these slides? Okay, I will try to do it, because as I said, it's you will find it with Arabic letter and at the same time English. So I have to make it mono language. So I'm working on it currently to have, as I said, separate presentations. You can find here on the top ultrafiltration and then Arabic, and after that I make English. So I'm trying, as I said, to convert it totally to English language. So you can, as I said, anybody can understand it and just make use of it. Okay. I hope I answered your questions for today. If you have a further question, please don't hesitate to give it.
Okay, thank you
Yes, my
very much.
dear. Yes, please. Continue. Go ahead, Doctor. I'm done already. So,
Okay, thank you very much, Honorable Sir. You have explained very well. And so, dear participants, we have concluded our today's session with the valuable module 2. See you tomorrow. Take care. Allah Hafiz.
okay. Assalamu alaikum.